So the plan for my video is, well, my goal is that I want to verify the precision of the opentrons at 1 microliters and 5 microliters because all we have, the lowest volume pipette we have for the opentrons is a P300. And when I try to use it and use volumes lower and try to make it pipette volumes lower than 20 microliters, it gives me a warning. So I wanted to see how inaccurate it was below 20 microliters and if it was accurate enough that we didn't need to worry about the warning. So what I'm doing is I'm going to make a BSA stock, a 10% stock, and I'm going to measure the OD 280 of it using a nanodrop, and then I'll dilute it and take the OD 280 of the dilutions. I'll be diluting it with the opentrons mostly, and also do one dilution of my own to compare. So first I got 0.1 grams of BSA, and now I'm going to be adding 1 ml of water to a 1.5 ml tube. I mixed it by pipetting up and down and by flicking it. Then I'll zero a nanodrop after this using 2 microliters of DI water. Then on the setting of OD280. Now I'm adding 2 microliters of the BSA stock that I just made to the nanodrop so I can get an initial reading. As you can see, it's already zeroed, since you can see the 0.005, and now the reading I'm going to be using for my initial reading is going to be 82.5 milligrams per microliter. Now I'm adding 9 microliters of DI water into wells A1 through A6, and I'll add, after that, 5 microliters of DI water to wells B1 to B6. This is the water that will be used to dilute the BSA. The opentrons will add the 1 microliters of BSA into the first 5 wells, and it will add 5 microliters of BSA into the first 5 wells of the B column. I will add 1 microliter myself to A6 and 5 microliters myself to B6 to test as a control. As you can see, you have to pipette, preferably straight to the bottom, but as you will see later, this is the 5 microliters reading that I used for wells B1 to B6. And here, as you can see, some of it was stuck to the side because of human errors in pipetting. And I'm going to be tapping it on the ground to have the liquid pool at the bottom of each well. This is the 1 microliter reading that I added. Wait. So for this step of the video, it was an error because I just wanted to show what volume I pipetted, which was 9 microliters, but I had 1 microliter in the video because I just forgot that I pipetted 9 microliters. This is my procedure. As you can see, it's going to be pipetting from H12, which is where I have uh, a large quantity of the BSI stock that I made. It's going to take it from there and add 1 microliter from A1 to A5. And then it's going to do the same thing for B1 to B6 with 5 microliters. This is how my deck will be set up. And those are the reagents. This is the opentrons taking it from H12, as you will shortly see, and then pipetting it into A1 to A5. Now it's taking it from H12 and it's going to pipette it to B1 to B5. 5 microliters, that is. So now that means A1 through A5 is diluted, has a BSA dilution of 1 to 10, and B1 through B5 has a BSA dilution of 1 to 2. Now I am myself manually adding 1 microliters to A6, so I can use it as a comparison for what the correct dilution would be, or the dilution of a human, to prove that the open trust is at least as good as a human. Now I'm adding 5 microliters of BSA stock solution to column B6. Next, I'm going to add 3 microliters from each of these wells into the nanodrop, which is already zeroed with the DI water from before. And I simply pipette it onto the small spot on the nanodrop, and then I measure each one individually. I cut it out because I'm sure you don't want to see me pipetting the same thing over and over and over. And now begins my data analysis. As you know, I blanked the nanodrop with 2 microliters of DI water, and then I ran that DI water on the nanodrop to make sure that it blinked properly. And as you can see on number 1, that is around 0 milligrams per milliliter, which means the blink was successful. Then I ran my stock, which was 1 to 10 on the BSA, with 0.1 nanograms per 1 milliliter, and it was 82 milligrams per milliliter. That's what I will be using as a baseline. Then comes my opentrons runs, where I made the opentrons pipette 1 microliters into 9 microliters of DI water that I added, and it was very inconsistent. It either pipetted 16 milligrams, either the OD280 was either 16 milligrams per milliliter, or it was around 13. Any one of those. It did 16 once, twice, three. It did 16 twice, and it did 12 about twice. My reading number 6, or the final A5, I believe, there was a mistake, which is why it shows about 0. But my first, number 3, was 16. My second, number 4, was 13. Fifth was 16 again. Sixth was a mistake. Seventh was around 12 again. So as you can see, the opentrons does about 12 or 16 milligrams per milliliter, which is about a 1 to 5 dilution, or between 1 to 5 to 1 to 10 dilution, when it should be doing 1 to 10, since it is 10% of that 10% stock. My number 9 is my by hand dilution, where I added 1 microliters by hand. As you can see, it is approximately 1 to 10, since it's 8 milligrams per milliliter about, which proves that it was not an outside factor, but the opentrons causing the problems, or maybe my protocol. Next is the 1-2 dilutions, where I added 5 microliters of DI water and 5 microliters of the BSA. As you can see, the opentrons makes less of an error, but still an error. Number 10 was just a human error. I added it to the nanodrop wrong, so that was the first sample of the opentrons, but most of the other ones were in the 50s, either the low 50s to the high 50s. And the one I did by hand, my human sample, was number 15. It was 51. And as you can see, this opentron sample, number 12, was 52. This shows that the opentrons at higher volumes is definitely much more precise. At 5 microliters, it was pipetting less than 1 to 2. It was like maybe 3 to 4 almost. Maybe 6 to 10 instead of 5 to 10 or 1 to 2. But it was still much more precise than the almost double the volume that it was pipetting when it was 1 microliters. And even me as a human messed up by doing, since as you can see, the milligrams per milliliters is 50.7 to 82, when it should be about 41. So the opentrons is not that much worse than a human, or me as a human. that would be the end of this video. And my final conclusion is that to not use the opentrons at 1 microliters. At around 5 microliters, it starts to approach human levels of precision. I'll have to do further testing to see it at 10 microliters, 15 microliters, etc. But at 20 microliters, it should be about perfect, since that is what it says in the manufacturer's website. I will do further testing on this to make sure. Thank you.